Yesterday, this left me and Jared stranded at the other property because it wouldn't start. It showed a quarter tank of fuel and it drove just fine over there, but I went to go leave and it wouldn't start. So I had my wife bring me a couple gallons of gas. We put it in and it started right up. Now it shows full. That's what I was afraid of. Every time I think I'm ready to take this van on a trip, something else comes up. So weird because when it runs really well, but when we were sitting there, Jared and I pulled the dog box off and checked for fuel pressure. There was almost nothing. So I bumped the key just to make sure that it was actually running. I don't know. I guess I'll have to look into that. Of course, now I filled the fuel tank. I knew better, but I wanted to see if the fuel gauge actually worked. And, well, you can see what happened. Before we dig into this, it's important to remember that when this left us stranded, Jared and I pulled the dog box off and checked for fuel at the fuel rail. There's a test port on there, and I just take the cap off, take the needle valve, push down on it with the cycle the key, and we had no fuel spray. We cranked it, had no fuel spray. So that's what led us to the avenue we're going to show you. But if it would have had fuel, some type of fuel, the next test would have been fuel pressure to see what it was, make sure we're in spec. Since we didn't have any, we went that way. If we would have had some type of fuel or adequate fuel pressure, we would have obviously looked for, got the scanner out and went that way, or looked for spark. But it's important to know that we knew early on that it was a fuel problem, and that's why we went the direction we did. Now, before we can diagnose that, we have to understand how the system works. So I have a rudimentary drawing I'm going to show you here. Before we can diagnose it, we need to look at the schematic. So we have a fuel pump driver module, a PCM, a restraint system, and the fuel pump itself. So the way this system works is that it is a returnless fuel system, meaning there's no fuel return. So whatever excess fuel wouldn't be used doesn't go back to return line. What they do is they speed the pump up and slow it down to give it the pressure that they're looking for and the volume. So what we have is we have 12 volt input here, purple and green wire. Brings ignition power in on when the key on to the fuel pump driver module. We have a ground out here to the frame, which is black and green. We have a line from the PCM, which is yellow and orange. This is a fuel pump control. This is what sends a signal to the fuel pump driver module to speed it up and slow it down. We have this wire here, which is brown and white, which is a fuel pump monitor line. This one is monitoring what the fuel pump driver module is doing. Then we have a restraint module input. So this one is yellow and purple. This takes place of the old inertia switches we were used to. So in the event of a crash, this module would turn off that fuel pump through the fuel pump driver module. And then we have our outputs to the fuel pump, which is a yellow and gray, which is the positive, and the negative is a white and brown. Now those two wires run as a twisted pair up to the fuel pump, and they have, that wire I showed you that was corroded, that there's a wire that's corroded, I'll show you, but it's coiled around here, and what this is doing, this is a shielding wire, and it's grounded on this end as well. So this wire here protects that line from any outside current, because you're varying the voltage that goes to this pump to speed it up and slow it down. So it doesn't want any outside interference changing what the speed of that would be. So what we need to do is make sure we have our inputs, we have a good power coming in, we have a good ground, we have good power coming out, and we make sure that what it's supposed to have here is what it has here. So now I can get into showing you how I diagnosed it. This van ran just fine, started fine, didn't have any problems until after I was in here doing the work that we did. So I started thinking about this, and this is a fuel pump driver module, and I didn't do anything with these wires, but I did look at them and move them. So I thought it's worthwhile to inspect them. And then, let's see here, I saw some corrosion. See that bare wire there? I don't know what that is, but there's also, it's hard to see, right there on that wire, I think someone has poked that wire with something, like checking to see if a signal, what it was, and it's corroded, so it's been a while. There we go. So I'm going to pull this apart and see what's underneath here, but it looks like we may have a hole in there where someone was chasing a problem or something, and now it's corroded. What I could do is try and start it and wiggle this and see if it shuts off or changes. When we crank, we have like no voltage. Go ahead and crank it. Crank. Alright. Okay. So the next thing I want to do is unplug the fuel pump and then see if that changes, because the fuel pump could be having a problem and dragging it down. Well, the next thing I'm going to do is disconnect the fuel pump up here and see if we have the same results. If the voltage stays up, that tells me that the fuel pump is pulling it down, pulling my voltage down, and that could be our problem. And it could be just the fact that when you jump it with 12 volts, it's enough to make it move and start the pump. Alright, so we're back probed in here. I've got a light set up for a load indicator, and I got my voltmeter set up. Turn the key on. Okay, the light comes on for a second. When it does its test, crank it. 11 volts. Okay, turn it off, turn the key back on. Let's test this line, make sure we can get 12 volts through here. So I'll send 12 volts back there at the module and make sure that this can get 12 volts. It has the ability. So now everything's still set up, but I have 12 volts sent from my 7-pin back there, my constant 12 volt, to the output of the module. So you see my lights lit up here, constant, and I got 12.5 volts. Go ahead and crank it. I'd like to stay above 10.5. Alright. Okay, so we're staying ahead of 10.5, so I would say we're good there. So I'm going to go ahead and condemn the fuel pump, and I guess we'll get one ordered and change it out. This is just a way to check the load to make sure that this wires that feed this are able to carry the load. And you see I'm using the positive and the negative, so I'm using the entire system from here all the way back to the module, including beyond the module to get to the ground, because we didn't run an external ground here. We wanted to check the circuits themselves as they are ran. So I'll go ahead and remove my jumper, and I guess we'll put a fuel pump in it. Hopefully that fixes it. So I got the fuel pump for this that I'm going to replace it with, but if you remember, I had just filled this tank up. It holds 33 gallons of fuel. I don't want to have to manhandle 33 gallons worth of fuel, so I came underneath here and I made this quick to connect steel fitting that snaps into the factory line. I disconnected it from the truck, from the van, ran it to this line here. I'm filling my gas cans. I'm just putting that gas in the other vehicles, the two other vehicles we have that are gasoline. And then to power it, I just took the fuel pump driver module, took that connector loose, back probe for the two wires that actually go to the fuel pump, and we're supplying power with that jump pack now. I unplugged it because if I didn't, we could be sending fuel or sending power to the rest of the system. I don't want to do that. I just want to isolate just the pump itself. So we'll do that. We'll get it emptied out, then we'll drop the tank. I think we're having a failure right there. It's look at how the hose is jumping.
Yeah, it wasn't doing that before at all.
It was smooth before. This tells us we have inconsistencies, whether it's the pump or if there's a regulator in line that the regulator's failing. I would bet it's the pump, being how we were having electrical problems. But look at that thing jump. My voltage is still good. Alright, turn it off. You can see how that's consistent with the way the pump sounds and surging. Alright, turn it on. So we got to take these tank straps loose. There's two of them. And we live in the Rust Belt, so everything's rusty. So we're going to take a wire brush. You can't get a wire wheel in there, but I'll take a wire brush. I'm going to clean these threads off. You see how long these threads are here, and they're necessary to get the strap started. So I'm going to go all the way around this real good, and then once I'm happy with it, I'll put some blaster on the whole thing to help it to come off of there. Now the tank's out. I took a blowgun, blew all the crap out from around this so we can get the locking ring off. I don't want any of that rust to fall inside there. It's really pretty simple. Filler neck and vent, that's all it's here. One vent line for the charcoal canister, evap, whatever. Second one here, and a fuel line. Two electric lines here, one electric line here. That's it.
Finally.
I have no idea why that was that hard. I don't see any water. A little bit of gas, not much. A little bit of rust, not much. We'd probably knock that in there right now doing this. Let's get this cleaned out. Just in case somebody else has to do this, they'll know when I replaced it. This is that line I made. That is nothing more than just a quick connect that I made with that Master Cool tool that I have. So now the fuel tank's back in, and we put 12 gallons of gas back in it. So at 12 gallons, this is 33 gallons, so it should show right around a third of the tank. So a little over a quarter, something like that. Just a little over a quarter. Now we want to see if we can hear the fuel pump run. Cycle that key a couple times. Just turn the key on first. I heard it. Shut it off. Cycle it on. Alright, start it. Well, starts and runs, so Check engine lights hanging on. I bet it's an evap code. So the fuel pump's back in now, and I am back probed into the fuel pump driver module connector at the fuel pump wires. So the two wires that lead up to the fuel pump, this would be the output. I'm back probed in each one of them so I can see what the voltage is with the key on, when it's cranking, and then when it's running, so we can get a look at that. Key on. It's like 10.5 volts. Go ahead and crank it. Yeah, it doesn't sample fast enough. It starts too fast now, but so running, currently it's supplying 7.5 volts, a little under 7.5. Raise the RPM up. Okay. Shut it off. Turn the key on again. Yeah, so it primes it up. It probably gives it the full 12 volts, and then go ahead and crank it. Yeah, we can't get a meter reading fast enough, but as you can see, when it's running, it's basically 7.5 volts right now. So that's how it's speeding up and slowing down the fuel pump. So as the load increases and it needs more fuel, it'll speed this thing up. So I hope that helps somebody, and that'll show you what you should be seeing at this driver module if you have a good pump or if your circuitry is good. So if you wonder what I'm talking about with back probes, I make these things out of MIG wire. So when I'm welding and I roll through, I run through a wire, a whole roll of wire, and you go to change it, there's a section left in the gun. So I just pull it out and I cut it into these lengths. This happens to be 30 thousandths MIG wire. And I just take needle nose pliers on the end of it and I just curl it up and create this end here. And it allows me to bend these however I need to. So if I need to go into a connector and I want to bend that at a 90 to get it away for something, I can do it. Who cares? It's just old MIG wire. And I keep some of these around. These are from caps, quarts for gear oil and stuff like that. And I just poke a hole in the end of it, and then when I use a alligator clip style hook, I can hook it right in here, and I can stay insulated from the other ones if need be. And I keep them, this is one of Jeff's old pill bottles. God knows there's enough of them around. I just keep them all in here. And if I need more, I lose some, not a big deal. I just go grab some more MIG wire. Keep them in my box of a meter. This is a cheat sheet for pressures. Like you see 80 degrees, which is about where we're at, 40 to 50 psi on the low side, and 175, 210 on the high side. So we're a little bit low on the high side and a little bit low on the low side. So she may just need a little bit of a charge. There we go. Now our temperature should be much better because now we're over 35 and we're pushing probably 180, 190, something like that. 185, 190. Let's see what the temperature feels like now. Good thing we're starting to get some evaporative water coming off. Oh yeah, that's a huge difference. Huge difference. See what that is, but it's adequate. So being I think it's good enough, we'll stop there. We'll watch our pressures for a little while and see what happens and go from there. I don't want to go any higher than where we're at now. I'd rather just see what's going to happen. Well, I guess the only thing left to do now is put some miles on it, or actually just restart it for the next however long till we feel comfortable that that is the problem fixed. I'm going to go ahead and order the tire pressure sensor so that that'll be one more thing off the list, and I think it's pretty well good to go if nothing else comes about. I'm unsettled on the leaf springs, whether I'm going to leave that or not. We'll see. but for right now, I guess we'll just continue to drive it and start it up occasionally and see how it's going to work. It seems to be running really good. I don't have any problems at all. So let's hope this is fixed. I'll just continue to try this and, you know, restart it every now and again like I had been. And I gotta tell you, if it starts okay for a couple of weeks, I would think we're good to go. So anyways, maybe this will help somebody try and diagnose your problem if you have the same. Thanks for watching. Catch you on the next one. Well, it's been sitting for about 18 hours. So let's see what it does. That's one for the good.